Okay, so a wonderful good morning, everyone. I welcome you to my YouTube channel. Presenting before you this wonderful tutorial is Hampeo Kliman. So to those of you that are new to this channel, just make sure that you subscribe and you also hit the like button, and also don't forget to share. And if you have a topic that you didn't understand, make sure that you inbox me on this WhatsApp line. Yeah, so we are still doing physics Olympics, and this time around we'll be tackling quite a lot of questions on projectile motions, since a lot of people find challenges in finding projectile motion. So make sure that you grasp and you understand. Okay, so we'll do three questions. We'll do three questions today, the most complicated ones, then we'll be going to those that are really easy for you. Okay, so let's get started. They're saying a ball is thrown directly downward with an initial speed of 8 meters per second from a height of 30 meters. After what time interval does it strike the ground? After what time interval does it strike the ground? Okay, so to start with the first question, the first thing that we're going to do is simply to draw an illustration. For the first one, it's very easy. So we have, let's say A. So this is the situation. You have a hill like this. Okay, then let's say this is the person who is standing here. Okay, then this person, they are saying that a ball is thrown directly downward. So this person throws a ball in this direction. We have a ball coming in this direction till it falls, reaching at this point. Now, accordingly to our data, we have been taught that we have an initial speed of 8.0 meters per second. Now, since where it's reaching, it's hitting the ground, and we expect it to be stationary, therefore the velocity final is 0.0 meters per second. And of course, we have been taught that its height is simply a 30.0 meters, like that. So you will learn quite a lot of things. I will be revising with you concerning the lecture that I had taught last time on projectile motions. So now this time around, they want us to find the time with which it strikes the ground. So we are taking motion in the y-axis. But then remember that I gave you an equation where I said y final is equal to v initial multiplied by the time minus 1 over 2 gt squared plus y initial. Okay, plus y initial, which is the distance in the y at some point, the initial. From here, now we know that the distance final, of course, is simply 0, because this is the distance final starting from. Okay, this is going to be the distance final, because imagine this is where it's coming from. This is down there. Then you're going against gravity. This is the top. So you imagine that's the final on top, and basically it's 0 because you're sitting from there. So of course you put your 0 here. But then we know that our velocity is simply 8.0 minus, then we know that this is 9.8 plus 30 meters. From here, this is just the same as 0 is equal to 8.0 t minus 4.9 t squared plus 30. So when you reach here, I think everything is done. This is just the same as negative 4.9 t squared. Now remember, this thing is going down there, so we expect the velocity to be negative. So we expect this velocity to be negative. It's going in the negative direction, so it's going to be minus 8.0 t plus 30 equal to 0. So now this is a quadratic equation. Your A is simply equal to negative 4.9. Your B is equal to negative 8. And your C is 30. So you can use this formula. We say time is equal to negative B positive or negative the root of B squared minus 4AC over 2A. The time is that one which is going to give you a positive t. So time is positive t. That's your time. So you take note of this. When you do the needful, you use this to find two values of t. The one which gives you positive is the answer. So this is just how simple the first question is. Let's get to the second question anyway. Don't have to waste time. So that one is very simple. Okay, let's get to the second question. No calculations. So for the calculations, you just insert in here, you know what to do. Okay, so we get to the second question. They are saying that the second question is saying the speed of a bullet as it travels down the barrel of a rifle toward the opening is given by V is equal to this number, t plus t squared plus 3 multiplied by 10 to the power 5t. Now, where V is in meters per second and t is in seconds, the acceleration of the bullet just as it leaves the barrel is 0. Okay, so you take note of that. Determine the acceleration and position of the bullet as functions of time when the bullet is in the barrel. Determine the time interval over which the bullet is accelerated. Find the speed at which the bullet leaves the barrel. So usually these are questions that you will need to be dealing with under this topic. So they're very tricky, but very simple. All right. Let's collect the data. So this one is a simple and straightforward illustration. Okay, so they've given you, accordingly to that data, they are saying that we have the velocity of, we have a velocity which is equal to negative 5.0 multiplied by 10 to the power 7, like this, t squared plus 3 multiplied by 10 to the power 5 t. Okay, so this is for V. Then they're saying the acceleration is equal to 0.0 meters per second. So if you don't know how to find this, then you just don't know. So make sure that you expand this and you will be able to understand everything more. All right, now they're saying that determine the acceleration and position of the bullet as functions of time when the bullet is in the barrel. So whenever you hear a question asking you to determine something as functions of this and that, just know that you have to involve calculus there. So in this case, for us to come up with the expressions of the acceleration and the displacement or the time or the distance, then of course we'll have to involve calculus. So we know that when we find dy dx, or let me say dv over dt, we're differentiating, then automatically we're finding the acceleration. So you differentiate velocity, you find the acceleration. You integrate velocity, you find the displacement. So let's do the needful. Okay, so we have v is equal to, let's find this as a function of acceleration. Okay, so this 0 multiplied by 10 to the power 7 t squared plus 3 multiplied by 10 to the power 5 t. So now we know that acceleration is equal to dv over dt, which is equal to, so we know that we need to multiply everything by this power. So this is just the same as 2 negative 5.00 multiplied by 10 power 7. Then you reduce the power by 1. Then of course for this one, you just take it as it is, but you just remove the variable. So you remove the variable to remain like that. Then of course we know that acceleration is equal to, this is going to be, so we know that you just multiply the numbers there. So this is mathematics. Negative 10.00 multiplied by 10 to the power 7, like that. And you say t plus 3 multiplied by 10 to the power 5. Okay, so this is for the acceleration. Now let's do for the displacement, or the distance. So for the distance, of course, we just integrate this. So we say distance is equal to the integral of v, which is just the same as 1 over 3 negative 5.00 multiplied by 10 to the power 7. This of course increases by 1, which is going to be 3, plus, since we have a t here, it will be 1 over 2, 3 multiplied by 10 to the power 5, then of course it increases by 2. Then of course we know that some distance, or the length, is going to equal to, this is 5 divided by 3, 5 divided by 5 divided by 3, of course we know that we'll get just a negative 1 point something. So this is going to be negative 1.67 if you round off, multiplied by 10 to the power 7, like that, t, like this, plus 3 divided by 2. 3 divided by 2. Of course, if we divide by 2, it's going to be 1 point something. Divided by 2 is going to be 1 point something, so it will be, okay, let me see, 3 divided by 3, okay, so it's going to be 1.5 multiplied by 10 to the power 5 t to the power 2. Of course, you get your thing. So this is just how interesting it is. Okay, so that's A. We come to B. B, they are saying, if so, what is its speed at the top? Okay, they want us to find the speed. What? Okay, they're saying B, determine we're on question 2. So determine the time interval over which the bullet is accelerated. We determine the time interval over which the bullet is accelerated. Okay, so how do you determine the time interval? It's very simple. So for the time interval, of course, we have an expression for the acceleration, and the expression is simply acceleration. Remember, we have found it. It's here. Where is it? It's here. Yeah, it's here. This one. So get this one, the one we found for acceleration. So it was negative 10 multiplied by 10 to the power 7t plus 3 multiplied by 10 to the power 5. Like that. The power 5. Then what you do, remember in the first place, we're taught that the acceleration just as the bullet leaves the barrel is 0. So since the acceleration is 0, we'll put 0 here and simply write this out. Like this, right? Then of course this can go this side, and of course it's going to be negative. Okay, this is gonna be, let's just put it as 10, positive 10 multiplied by 10 to the power 7, t equal to 3 multiplied by 10 to the power 5 over 10 multiplied by 10 to the power 7 over 10 multiplied by 10 to the power 7. Divide this, of course. Let's calculate. Okay, sorry. Okay, so you get a value of 0.003 seconds. Okay, let's get to say they are saying determine the speed at which the bullet leaves the barrel. Okay, so for the speed, it's very simple because already, okay, this is C. Already you know what to do here. Don't even have to waste time. Where? Remember your expression for the velocity is here. So you just write the same out. So if we write this one out, of course, it's going to be V is equal to negative 5.0 multiplied by 10 to the power 7 t squared plus 3 multiplied by 10 to the power 5 t. Now remember you have the time. So since you have the time, this becomes very easy. Just do the needful. You put your 0.003 here. And you put your 0.003 here. Calculate everything. You expect something to be... Okay, so I don't have to even waste time. I already did this. Already calculated this. So it gave me something like 450 meters per second. So if you found that variable, then of course you found the right answer. Okay, so this is quite easy. Let's go to the third question. So the third question is saying an attacker at the base of a castle wall 3.65 meters high throws a rock straight up with a speed of 7.4 meters per second from height 1.55 meters above the ground. Will the rock reach the top of the wall? If so, what is its speed at the top? Find the change in speed of the rock thrown straight down from the top of the wall at an initial speed of 7.4 meters per second and moving between the same 2 points. Okay, so that's the change, that is D. So of course these questions are very, very, very simple but tricky. Therefore, it's very important to attempt quite a lot of questions under projectile motions. attempt quite a lot of questions. Let's get started. Okay. All right, so this is an interesting question. Okay, so we're going to imagine that this is the castle base. Okay, something like this. I don't know how you draw this thing. I don't know, this is a castle. Something like this. Looks like a bone. It's a castle. All right, then let's say we have a person standing here. Okay, let's name this as an attacker. So physics is very complex. Okay, it's complex, it's wide. So make sure that you just know how to, whichever diagram that you can use, okay, provided it's able to give you something. Now they're saying that an attacker at the base of a castle wall, 3.5 meters high. Okay, so let's imagine that this thing here, its height is simply 3.65 meters. I throws a rock straight up with the speed of that. So this guy throws a rock in this direction. It's a rock in this direction. Okay? Like that. Now the speed at which this person throws this, we have been told that it's 7.4 meters per second. Okay, from height of that. So of course, the height at which this person is, please don't mind my diagrams. The height, okay, let's say this person, the height at which this person through this was, what's this, 1.5 meters. So with that, let's get into the question. They're saying, will the rock reach the top of the wall? So how can you can't answer this question unless you find the speed at which this rock was moving. So the speed will help us with everything. The speed will help us. Let's try to calculate the speed. Of course, in my previous video, I told you if you want to find the speed, there are quite a lot of formulas. So this is v to the power 2 equal to u squared minus 2. Okay, this is going to be 2g, some change in y. Remember this formula, it can be expanded. So this is just the same as y final minus y initial. And of course, this is going to be v squared equal to, what is v initial? It is 7.4 meters minus 2, this is 9.8. Then in here, the final, we imagine it's going to be 3.65 because that's the tallest, minus the initial, which is 1.55, like that. Then from here, okay, let's try to punch everything. This is 7.4 minus 2.9.8. Okay, multiplying by these brackets, 3.65 minus 1.55. Okay, so you get approximately something like 13.6. Okay. Okay, so, okay, 13.6, something like this. Okay, it's supposed to be a square here. Now when you reach here, this is very interesting because if we find the square root of this guy here. What do you discover? You discover that you're going to get a speed of, let's say, square root. My calculator. This calculator is not really working well. Okay, but square root of, let's say, square root of 13. Square root of 13.6, of course, we'll get 3.69 meters per second. Now, my question is, when we reached at this stage, that is where the conclusion is, did we find a positive answer or a negative answer in the square root? It's a positive. So since it's a positive, then it simply means that it's a positive, so it will reach the top base of the castle. Okay, so that's the conclusion. If we found the negative, then automatically it wouldn't have reached. It was going to be, it wasn't going to reach. Okay, but since inside we found some positive value, then of course we know it's going to reach. Okay, so for A, will the rock reach the top of the base? Okay, the rock will reach the top of the base. Yeah. Then B, what are they saying? They're saying, if so, what is its speed at the top? Okay, so when it reaches the top, what is its speed? Of course, we've calculated it's just here, 3.69 meters per second. Okay, let's get to some other question. We're on what's this? C. Find the change in the speed of a rock thrown straight down from the top of the wall at an initial speed of that. So they've given us the initial speed. Now they want us to find the change. Okay, so let's try to do the needful. All right. So we're on C. Now, for this one, it's very simple. It's just one and the same concept. You first of all bring out a formula. This is minus 2 G, the change in Y. The same thing applies. It's V2 equal to U to the power 2 minus 2G Y final minus Y initial. Now for this one, you need to be very careful. You need to be very, very careful, because the question is saying, find the change in speed of a rock thrown straight down. Now this rock is not going upward, it's going from up to down. It's going from up, it went at the top, now it's coming from the top, now it's going downward. So when it's going downward, you just have to change the initial heights. Okay, so you change the initial height. Since it's coming from up there, the speed from up there is, the distance from up there is going to be our final, and since it's going downward, the distance down there is going to be our the speed, the distance down there is going to be our final, and the distance up there is going to be our initial. So in this case, we have V to the power 2 is equal to, of course, this is 7.4. We have been taught this is going to be 9.8. Here, this is what I'm talking about. This is what I'm talking about. So since coming from up there, this is going to be 1.5. It's going to be final. Okay? The 1.5, this one. Okay, since in the first place it was going upward like that, this time around they want us to calculate when it's coming from upward, now it's going downward. So this one is going to be our initial, this is going to be our final. You understand? So this is going to be 3.65. Punch everything on the calculator. This is quite interesting. This calculator is really giving me problems. Punch everything at the same time, you must get roughly about 95.9 square root of 95 is giving me somewhere 9.7. It's giving me 9.79 meters per second. Now, is this supposed to be negative or positive? Of course, it will be negative. Why? Because the rock is going down there. Okay, so it will be negative. Please, a negative in physics doesn't mean it's a negative answer. It simply means it's the direction of the rock. It's going down there. Okay. Now the question was, find the change in speed of a rock thrown straight down from the top of the wall at an initial speed of that and moving between the same 2 points. So now we want to find the change in speed. Equals to speed final minus speed initial. So of course, change in speed is going to be, what is our speed final? Of course, we found 9.79 minus, what's the initial? It was 7 point something, 7.4, and our answer is going to be 2.29 meters per second. That's the answer. For D, they're saying, does the change in speed of the downward moving rock agree with the magnitude of the speed change of the rock moving upward between the same elevations? So for this one, you just have to subtract. That height from that speed. This speed, you calculate the speed when it was going upward from that initial speed when it was going downward. So of course, for D, you say 3.69 meters per second. Just subtract it from that initial speed up there, and you get something like, it's a negative answer, of course. So you get something like 3.71. Does it match with this? No, this one is bigger than this. So you say it therefore does. Okay, so just says therefore does not agree with C. Okay, doesn't agree with C. So this is how we go about these questions. Very interesting questions. So if you have a question, you want to ask something, inbox me on this WhatsApp line and I'll be able to respond to you. Thank you so much.